Alright, hello everybody. Hope you guys are doing good today. This is Mr. Parham with another lesson in Module 1. Go ahead and, if you haven't done so already, just put your phone away and complete the bell ringer in Canvas. And then pause the video to do that and come back whenever you're finished. Alright, number 2 here. Make sure at some point, like right now, you go to joinpd.com and using the code here at the top right, RNFIIV. Go ahead and join this presentation if we're doing this live in our virtual class. That way I can monitor your responses and your progress through the lesson and give you feedback as you go. And this is a mandatory step, so make sure you go ahead and do that if we're doing this with our virtual class. Alright, and then finally step 3, get out paper and pencil to write down notes, write down any questions that you might have that you need to ask later, and to work example problems, because the more you write, the more you remember. Alright, so let's go ahead and jump right in. We are still in Module 1, which is the atom, and today we're covering Section 3, which is titled How Atoms Differ. Remember, the first two sections were basically laying the groundwork for the history of the development of the atomic model, and now we're going to talk about, well, how are atoms different from one another. Okay, that's what we're going after today. Alright, we got two main objectives. So number 1, we want to be able to determine the number of subatomic particles for a particular isotope of an element. Remember, subatomic particles are particles that are smaller than an atom. Sub means below, so below the size of an atom. And then an isotope is going to be a certain version of an element. We're going to talk about what isotopes are. So don't worry necessarily if you don't know what that is yet, but we will learn. Okay. The next objective is to calculate average atomic mass for an element based on the abundance of its isotopes. Abundance just means how many of each isotope is there. If there's like 99% of all elements or all atoms of this element are one isotope, then that's a very high abundance, if that makes sense. Okay, so we're going to talk about those two things today. And let's go. Review vocab. Remember, the periodic table is a chart that organizes all your known elements into a grid of rows and columns. And the periodic table is going to be arranged in order of increasing atomic number. So we have a periodic table linked in our course. I'll show you where you can find it. Under the Modules tab and Course Resources, if you click into this CR.1 periodic table and reference sheet, right here it'll load you a periodic table. And you may have to rotate this thing. If you hit this rotate arrow, it'll turn it upright for you. But this is what your periodic table is going to look like. And you can see, like, it's arranged in order of atomic number. So 1 is hydrogen, 2 is helium, 3 is lithium, and so on and so forth. We're going to refer back to this throughout this lesson. So I'm going to keep it open here, and I recommend that you have it open on your screen as well. And you can go back and watch to see where to find it if you forgot. Okay, but that's not where I want to be. Here it is. Our new vocab, we're going to talk about what atomic number means. So we just said it's arranged in order of atomic number, but what does the atomic number even tell us? We're going to learn what isotopes are, what mass number is, what an atomic mass unit is, and then what atomic mass is. These are our new vocab words for this lesson. Okay? Alright, so this starts with a video. And the video is going to tell us a little bit about the nucleus. So go ahead and pause this video, open the one on the slide in a new tab, and watch it. Whenever you're finished watching it, hopefully you've gotten something out of it, come back and continue this lesson. Alright, I'm going to go ahead and move on. Okay, so what is the atomic number? It's something that we can get from the periodic table, but it also tells us something about a certain atom. So each element contains a unique positive charge in its nucleus. If you remember whenever we talked about Ernest Rutherford, the nucleus that Ernest Rutherford discovered with his gold foil experiment was a dense region of positively charged particles. And so each element has a different charge or a different number of protons in its nucleus. Okay? That's what sets elements apart from one another. If you have two atoms with the same number of protons in the nucleus, then those two atoms are of the same element. if I have two atoms with different numbers of protons inside the nucleus, then those two atoms represent different elements. Okay? Alright, so the number of protons in the nucleus of an atom identifies that element, and it's known as the atomic number. So here is an entry from the periodic table. If you look at the top, hydrogen will be the name of the element. The atomic number will be directly below. It'll be just an integer. In this case, it's 1 for hydrogen. And this 1 tells us hydrogen has a single proton in its nucleus. If I add a proton, look, go to my periodic table. If I add a proton, in other words, I add another positive charge to my nucleus, now I'm looking at a helium atom with an atomic number of 2. Alright, so hydrogen always has 1, helium always has 2, lithium always has 3, and so on and so forth. Okay, so again, atomic number will tell you the number of protons inside of the nucleus of an atom. Okay, and the atomic number is unique for each element. You can't possibly have two atoms of the same element with different numbers of protons. Alright. Here's another short video that's going to talk to you about what isotopes are. I'm not going to play it during this video, but you can pause this video, open this one here in a new tab, come back whenever you're finished. Basically, I want to describe isotopes and just kind of give you an analogy. So we know that there are different breeds of dogs, right? But at the end of the day, they're all dogs, but you have different types. So you have like German Shepherds and Dalmatians, and you have Chihuahuas and Poodles, right? These are all different breeds or versions of dogs, much the same way that you would have like different versions of a certain element. So you might have carbon element that has 6 neutrons in it. You might have one that has 8 neutrons in it. You might have one that has 7 neutrons in it. And so these are different versions of the same element, right? So you can think of isotopes as maybe you've got 3 carbon atoms lined up next to each other, but maybe they're different versions of that carbon atom. Much like you might have 3 dogs lined up next to each other, but they're all different breeds or different versions of dogs, okay? So just think about it in terms of those comparisons, and I think that should be helpful. If it's not, let me know. Alrighty. So talking about isotopes and mass number. All atoms of a particular element have the same number of protons and electrons. Okay, let me say that again. All atoms of a particular element, so if I'm looking at 50 million carbon atoms lined up, all 50 million of those atoms are going to have the same number of protons, because the number of protons is what makes it carbon. Okay, and it's going to have the same number of electrons, because positive charges and negative charges have to balance each other out. Matter is neutral, so if I have 6 protons, I always have to have 6 electrons to balance those charges out and make my atom neutral. Okay? So all atoms of a particular element have the same number of protons and electrons, but the number of neutrons in the nucleus can differ. So I can have 6 neutrons in my nucleus for carbon, I can have 7, or I can have 8 even. Okay, this is where the differences come in. This is where I get different versions of the same element, is whenever I have different numbers of neutrons. Alright, so atoms with the same number of protons, but different numbers of neutrons are called isotopes. So whenever you see the word isotope, you're thinking I have 2 atoms of the same element, but they just have different numbers of neutrons. So I can have 2 carbon atoms, one with 6 neutrons and one with 8 neutrons. This would be carbon 12 and this would be carbon 14. Those are 2 isotopes because they represent the same element. They have the same number of protons, but they'll have different numbers of neutrons. Okay? All right. And so the relative abundance of each isotope is usually constant. Relative abundance just means like how likely are you, if you have 100 carbon atoms, how likely are you to randomly pick one and pull out a certain isotope? So, it's like if I have a bowl of M&Ms and there's 100 of them and 99 of them are green and one of them is blue. My relative abundance of M&Ms would be 99% green and 1% blue, because that's just the ratio that they exist in nature, or in this case in my bowl, right? It just means how likely are you to find a particular isotope of that element. All right, so isotopes containing more neutrons have a greater mass. That makes sense because, remember, all of our mass is contained within the nucleus. So if I add more things to the nucleus, I add more mass. The more neutrons you have, the greater mass you have. And that's true for protons too. Atoms with more protons will also have, generally speaking, a higher mass. Okay? All right, and then isotopes have the same chemical behavior. So if you can remember from our lesson yesterday, we mentioned that if you want to know how an element or a chemical will behave, you just need to look at the number of electrons that it has, or how its electrons are arranged. And so isotopes all have the same numbers of protons and electrons, so then their chemical behavior doesn't change, because the thing that you look at, the electrons, is the same for every isotope. Remember, the only thing that differs is the number of neutrons. Okay? And then finally, there's this other property called the mass number. And it's the sum of the protons and the neutrons in the nucleus. Okay? And that should also make sense to us. Because remember, considering that all of the mass in an atom is contained within the nucleus, then those particles, protons and neutrons added up, will give me my mass. All right, so the mass number is just adding up all of the particles inside my nucleus. You add the protons plus the neutrons. All right, so I've got an example for you. Here I've got 3 different isotopes. These are all potassium atoms, right? We go back to the dogs analogy that we talked about. These are all dogs, but these are all different breeds of dogs. So these are all potassium atoms, but these are all different versions of potassium atoms. So this has 20 neutrons, this has 21 neutrons, and this one has 22, right? But all of them are potassium. They're just different versions, different isotopes. All right. So if I want to figure out how many protons, neutrons, and electrons I have, it's potassium. So potassium, if I look at my periodic table, is here, K, and look, it's atomic number 19. So atomic number 19 will tell me, hey, I've got 19 positive charges in my nucleus, or 19 protons, and since I have to have 19 negatives to balance that out, I'll have 19 electrons. And you'll notice those are the same for all potassium atoms. Okay? The only thing that's different is if my mass is 39, which is what this number represents here, then I have 19 protons. That means the rest of that 39 has to come from neutrons. So I need 20, because 39 minus 19 will give me 20 neutrons. Right? Same thing here. 40 mass, 40 like particles in my nucleus, minus the 19 protons gives me 21 neutrons, and so on. All right? So I want you to try this. Go ahead and pause this video and try and fill in this table using the text box feature on your response thing. And once you feel like you have it, then come back and check your answer. So look for the symbol. You're going to type the name of the element with a dash and then the mass number. And then you're going to put the number of protons, neutrons, and electrons along with these two as well. Okay. Let me tell you this, though, because whenever it's written like this, the 13 down here is the atomic number, and the 27 up here is the mass number. All right, that's how this symbol notation looks. You have the element symbol, the atomic number, and the mass number. All right, so if I look, aluminum is here. It's Al. There's the symbol. There's the atomic number. And then the isotope had a mass number of 27, so that's why that was on top. All right, try and fill this table out. Come back when you're finished. I'm going to go on. All right, there's our answer. So again, this is aluminum. That's the symbol for aluminum, dash 27, because that mass number is 27. My atomic number is 13. You can get that from 13 there, or you can get it from aluminum being number 13 in the periodic table. My mass number is 27. You get that straight from the symbol here, the top number. And then my protons has to be the same as my atomic. Electrons have to be the same as protons. And then to get neutrons, I subtract mass number minus my protons. Okay? And then same deal here on this table. So if you have any questions about that, filling in that table, let me know, and I'll try and help. All right, so I want you to stop here for a moment, and I want you to visit the Canvas page and navigate to Module 1 and go ahead and work on that isotope chart assignment. It's 1.3.1 isotope chart assignment. We're going to stop here for a bit, work on that assignment for about 10 minutes or so, and then come back to this lesson. So to find that, you're going to go to Canvas, you're going to go to Modules, you're going to go to Module 1, and then you're going to find the isotope chart assignment. And just click into it and work on that for about 10 minutes just to get you a little bit of practice doing these things. All right. Once you're done with that, after 10 minutes or so, come back to the video. We're going to finish. Let me know how you're feeling. If you're confused about any of the things that we've talked about, give me like yellow or red. And if you have any questions, then shoot me a message on Canvas or on Remind or whatever it is that you talk to me on, and I will try and help you the best that I can. All right. I think I'm almost done. I got just average atomic mass to talk about, and then I'm finished. So, now that we know what an isotope is, and what protons, neutrons, electrons are, atomic number, all that, we can talk about average atomic mass. Okay? So, one atomic mass unit, or abbreviated as AMU, is defined as a unit of mass that's used to express atomic and molecular weights, and it's equal to 1/12 the mass of a carbon-12 atom. All right, that's the very technical definition. Basically, think of it like this: one atomic mass unit is equal to the mass of one particle inside the nucleus. All right, so one proton has a mass of one atomic mass unit. One neutron has a mass of one atomic mass unit. And so carbon-12, it has 6 protons and 6 neutrons. Those added together will have a mass of 12 atomic mass units. So that's what that number represents right there. It tells you carbon-12 atom has a mass of 12 atomic mass units. All right? It's just we use atomic mass units because it's a lot more convenient than saying, 9.1 times 10 to the minus 28 grams or something like that. Something that is just so small that it's difficult to work with. So we use atomic mass units when talking about particles. All right, so again, one AMU is nearly, but not exactly, but for this purpose, for the purposes of this class, we're going to assume or round off that it's about 1. One AMU is equal to 1 proton or 1 neutron. Look at the electron here. The mass of an electron in AMUs is 0.0005. You can just assume for our purposes that that's 0, right? That's practically 0. It would take you something like 5,000 electrons or 2,000 electrons to even have the same mass as a single proton, and it's just not practical. So assume electrons have a mass of 0, protons and neutrons each have a mass of 1, and then you should be straight with this stuff. Okay? All right, we're going to talk about how to calculate average atomic mass. So the average atomic mass of an element is the weighted average mass of the isotopes of that element. I'm going to go to the whiteboard here because I want to show you exactly what they did. This is slide number 23. All right, if I could type, that would be excellent. Slide number 23. There we go. All right, so basically what we've got going on here is we have 2 isotopes, 2 versions of a chlorine atom, and we want to know what is the average atomic mass of these chlorine atoms. Okay, and here's how we're going to find that. We're going to look at one isotope at a time. So if we look at chlorine, 35 first, here is the atomic mass, and here is how likely you are to find that isotope in nature. So all I do is I multiply those 2 numbers together, but first I have to convert that to a decimal. So percent to a decimal is 0. Remember, I divide by 100 to get it back to a decimal. If I multiply that number by the atomic mass of that isotope, sorry, I've messed up. It's going to be 34.7 8.969. Once I multiply those two numbers together, I'm going to get, for that isotope, how much of a contribution it makes to the average atomic mass. And whenever I multiply this together, I get 26.499. Okay? Whenever I do the same for chlorine-37, and I want to know, what is that one's mass contribution, I take what is the mass of that isotope, I take how likely am I, what percentage, how abundant is it, how likely am I to find that isotope in nature, I multiply the two numbers together, converting the percentage to a decimal, of course, and then I get that. And then to get my average atomic mass, my last step, so just add them up. 8.9531. And if I add those up, then I don't know what I get off the top of my head. It's not anywhere on this slide. But if I add them up, I get something close to like 35, give or take. All right, I get a little bit more than 35, I think. Okay, so add those up on your calculator, and then whatever you get as your answer will be your average atomic mass. Okay, you find how much of your mass is a contribution from this isotope, how much of your mass is a contribution from this isotope, and then just add them up. It's actually the same way your grades are calculated. So if you have like 40% of your grade is a test, 25% is a quiz, 20% is daily work, and then 15% is like an EOC. You're going to multiply those percentages by your grades in each of those categories. So if your daily grade is 100, and then if your test average is a 78, and then your quiz average is an 81, and let's say you do really well, you get like a 90 on your EOC. If you want to calculate your final grade, it's the same thing. Multiply the abundance, how much your category is worth, by what your score was in that category. Add them all up, and you get your total grade. All right, so same thing with this, same type of formula. All right. If you want to see the formula written out, here it is written out. Basically, I'm going to say percent abundance. I'm going to say percent abundance right there. And then this is going to be like of the first isotope times the mass of the first isotope plus the percent abundance of the second one times the mass of the second one plus, and then ... until however many different isotopes you get. So there's your official formula. I want you to try and answer this question. Once you've answered this question, come back, pause the video, do that right now, come back, and then we'll go over the answer. All right? So I'm going to go ahead and go on the next slide. Spoiler alert. Boom. All right, if you got 69.72 AMUs, then excellent job. Then it means you did it right. So the way that should have been set up, and I'm not going to actually do the calculation, but look, my isotope is gallium-69. 69 is your mass right there. And then here is your percent abundance. Here's how likely you are to find that in nature. So I'll do, 0.6011 after converting that percentage to a decimal times 69 plus, I've got gallium-71. 71 is my mass. Here's the abundance, the 39.89%. So convert that to a decimal times 71. Okay, and I actually should have used these for my masses. So instead of 69, it would be 68.926. I'm sorry. I got ahead of myself. And instead of 71, it would actually be 70.925 right there. But once you multiply those numbers together and get answers and then add them, you'll get 69.72 as your final answer. All right, so that's how we do average atomic mass. That's how we do that. Go ahead and do this example as well. This one won't actually ask you to calculate anything. It's just saying if your final answer is closer to one or the other, which one of them is more abundant? Which one of them are you more likely to find in nature? Okay, so think about the M&M example. If I have 99% green versus 1% blue M&Ms, I'm more likely to find green, so my overall answer is going to be more likely green, right? So if I'm more likely to find 85, my answer will be closer to 85. If I'm more likely to find 87, my answer will be closer to 87. So that's what this question is asking. So figure out which one of these do you think is more abundant. Pause, answer, come back, and I'll give you the answer right now. Spoiler alert. Boom. Oh, I didn't give you the answer. But spoiler alert, it is rubidium 85 would be the answer for that, because look, 85.47 is closer to this number than it is to this number. All right, so this means that this number has to be the more abundant one. Okay. And I just realized I've not even been doing it on here. I've been doing it on the whiteboard. That's fine. All right, so we've got a couple multiple choice questions. Go ahead and answer this one. Unknown element has 19 protons, 19 electrons, and 3 isotopes with 20, 21, and 22 neutrons. What is the element's atomic number? So remember what atomic number asks you for. What does it tell us about the atom? And then you should be able to answer this question. Pause, answer, come back. I'm going to the next page right now to reveal. Okay, so you should have said 19. Remember, the atomic number tells you how many positive charges are inside of a nucleus. It tells you how many protons you have. So if you have 19 protons, then your atomic number is 19. Okay? Next, go ahead and answer this question. Elements with the same number of protons and differing number of neutrons are known as what? So pause, answer, come back. I'm going to give you the answer right now. All right, and then you should have said isotopes. So remember, it's like the example with the dogs. So if you've got like different breeds of dogs, then those are similar to having like different versions of the same element, where you have elements with the same number of protons but different numbers of neutrons. All right, that's it for this lesson. So this lesson is done. If you have any questions, feel free to ask on whatever platform you can communicate with me on. I will answer as quickly as possible. And go ahead and complete the exit ticket. And the assignment for the lesson, the second part, is going to be 1.3.2, average atomic mass assignment. All right, and ignore the due date here on the presentation. I'm not going to make it due tomorrow. I'm going to make it actually due the last day before we take the test. All right, so it'll be due kind of at the same time as your study guide. But go ahead and get it done if you have an opportunity. Don't put it off until the very end. If you have time to get it done, get it done. All right, but with that, I'm going to go ahead and get off of here and sign off. I hope this made sense. If you have any questions, let me know, and I will see you guys next time.